Let's take a journey through the fascinating world of brain's chemistry and circuitry, where neurons, monoamine axons, and their pathways dance in a delicate balance. Imagine neurons communicating across axons, some of which can undergo axonal degeneration, impacting neural networks. Critical players like substantia, nigra, pars compacta, the dorsal striatum, and the ventral striatum, home to the nucleus accumbens, are key regions involved in motivation, reward, and movement. Now picture the locus coeruleus and raphe nucleus as the brain's own chemical messengers releasing norepinephrine and serotonin respectively, influencing everything from alertness to mood. The ventral tegmental area fires dopamine into the ventral striatum and nucleus accumbens, fueling our feelings of pleasure, though sometimes this system hits a hypodopaminergic slump, leading to symptoms like anhedonia, that pesky inability to enjoy things. To manage these imbalances, antipsychotic medications like chlorpromazine and haloperidol come into play, targeting D2 dopamine receptors to modulate overactive pathways. Conversely, psychostimulants such as amphetamine and L-Dopa boost extracellular dopamine, temporarily lifting low dopamine levels and improving working memory, decision-making, and interference control, especially in areas like the prefrontal cortex and dorsolateral prefrontal cortex. But it's not just dopamine at work. The glutamatergic pyramidal neurons with their excitatory signals interact with GABAergic interneurons to fine-tune neural activity. Sometimes drugs like phencylamine and ketamine, acting as NMDA receptors antagonists, can cause excitotoxicity and apoptosis, especially through overactivation of microglia and astrocytes, leading to neurotoxic effects. These neuroinflammatory responses involve cytokines like interleukin-1 beta, interferons, tumor necrosis factor, and interleukin-10, which influence neuroimmune interactions and can contribute to neurodegeneration. On the metabolic side, the kynurenine pathway, starting from tryptophan metabolism via enzymes, produces neuroactive metabolites such as kynurenine, kynurenonic acid, and quinolonic acid. Supporting all this is the role of neurotrophins like brain-derived neurotrophic factor, fostering synaptic development, plasticity, and axonal guidance, so adhesion molecules help stabilize synapses, ensuring proper neural circuit formation. Across the brain, from the hippocampus's dentate gyrus to the occipital, temporal, and prefrontal cortices, a complex web of neurotransmitters, dopamine, serotonin, norepinephrine, GABA, and glutamate coordinate to keep our cognitive function sharp and our mood balanced. When these systems falter or become dysregulated, it can lead to a cascade of effects, from neurochemical imbalances to structural changes, reminding us just how beautifully intricate and resilient the brain truly is.